Hello everyone. Today I am presenting a project Sonar AI model for rock versus mine prediction. In this project, I develop an AI model that can identify whether an object underwater is a rock or a mine using sonar data. This technology has vital application in areas like maritime defense, underwater exploration, and safety measures for detecting potential underwater threats. Introduction. Let's start with sonar. Sonar stands for sound navigation and ranging. It sends sound waves underwater, and when these sound waves hit an object, they bounce back as echoes. By studying these echoes, we can figure out what is underwater, like whether the object is rock or something dangerous like bomb. The goal of this project is to create an AI model that automatically classifies sonar signals into two categories, rocks or bombs. I use a machine learning algorithm called support vector machine to do this. Problem statement. The main problem here is that sonar signals from rock and bombs are very similar, which make it hard for humans to tell them apart manually. This process can take long time and might lead to errors. So by using AI, I aim to automate the classification of sonar signals, making the process faster and more accurate. For example, a ship might use sonar to navigate the ocean, and it's important for the crew to know whether they are facing a harmless rock or a dangerous bomb. Now let's talk about why this is important. In military situations, misidentifying an object underwater could lead to life-threatening consequences. This AI model can help by making quicker and more accurate decisions. It also useful for commercial exploration or scientific research. For example, companies searching for oils or scientists studying ecosystems would benefit from accurate object identification. This technology can improve efficiency and safety. Methodology. I use support vector machine, a machine learning algorithm that help classifying data. In simple terms, SVM creates a boundary called hyperplane to separate two categories, in this case, rocks and bombs, based on sonar signals. First, I load the sonar data, which contains signal reflecting of both rocks and bombs. I split the data into two parts, 80% for training the model and 20% for testing it. Before training, I normalize the data to make sure all the values are on the same scale, which help the algorithm learn better. Finally, I train the SVM model and test its accuracy on the test data to see how well it works. Implementation. I load a dataset that has 208 sonar readings. Each reading represents either a rock or a bomb. I normalize the data, which is an important step because machine learning models like SVM perform better when the data is scaled properly. I train the SVM on 80% of the data, teaching the model how to separate rocks from bombs. Then I test the model on remaining 20% to see how well it performs on unseen data. Here's a visual of how SVM works. Imagine two types of data, orange circle for rocks and blue circle for bombs. The black line in the middle is called hyperplane. This line separates the two groups. The point closest to the line called support vector helps define whether the line should go. When the new data comes in the model can classify it based on which side of the line it can fall. Here are the output images of my model. Results. After training the model, I achieve an accuracy of 92%. This means that the model correctly classified 92 out of every 100 sonar signals. The SVM algorithm worked well because it found the best way to separate rocks and bomb based on the data. I found one thing that normalization play a huge role in improving the accuracy. When I trained the model without normalizing the data, the accuracy was only around 80%. But after the normalization, the accuracy increased up to 92%. This highlights how important normalization in machine learning. Conclusion. To conclude, I successfully used support vector machine to classify sonar signal with an accuracy of 92%. This project shows the potential of using AI in a real world application like defense, underwater exploration, and resource discovery. For future work, I would expand the dataset to include more types of objects and explore other advanced algorithms like deep learning to see if I can improve the model performance. The goal would be to implement this in real-time sonar systems to classify objects instantly during underwater operations. Lastly, I would like to acknowledge the research that I helped me in this project. Here are some key references that I use. Thank you.